Hello, welcome to Chapter 16 for Business Math called Marketing. We are in Lesson 16.7 called Pricing. So this is the last section for Section 16. As always, you should be reading the chapter or the lesson for each worksheet. Go through, pay attention to the vocabulary and the concepts they're asking you to understand. And as you look through the examples, don't just look for how to do the problem, but why. So why am I multiplying these numbers? What does it give me? The more you understand, the better you'll be able to apply this as we move through the book. And honestly, when we get down to like the algebra problems, the more we understand the why, the more we'll understand what to do when we get down to the algebra type problems, the application type problems. All right, so let's go ahead and read our summary here. The selling price of your products must be high enough to cover expenses and to make a profit. The net income of your sales should be high enough to cover all your expenses and still allow you to make a profit. So possible net income is going to equal your selling price per unit minus your total cost per unit. And we'll talk about how to calculate the total cost per unit in a moment, times the estimated unit sales. So total cost per unit, when you have a warehouse or a store, there's two different costs, and we'll look at that in this table when we get down here. We have fixed cost per unit and we have variable cost per unit. So fixed cost per unit have more to do with building expenses and things that are fixed. They don't really change, but these are the costs that are associated with this product or this unit. Variable costs have to do more with things that vary, like employee hours or something along those lines. So total cost per unit means that we want to add those two costs together. So we know, what does it cost us overall to have this product? And then we have selling price per unit. That's just, what are we selling it for? So we're going to subtract the cost from the selling price. And then we're going to multiply that by how many we estimate to sell so that we know, our possible net profits. All right. So let's go ahead and take a look at which selling price yields the greatest possible profit. Oh, sorry, didn't read the first sentence there. Complete the table below for Bloomers, a local florist. Which selling price yields the greatest possible profit? How many units of the arrangement should be produced to maximize the profits? All right. So what we want to do is just go across and multiply. So first, fixed cost per unit, we want to take and it's kind of written in the way we want to divide this. So fixed cost, per means divide, unit. So we have fixed cost per unit, like that. So we actually want to divide fixed cost per unit, so that we know how much, and I'm going to go ahead and pull my calculator up here. So we know how much the fixed costs are for every unit that we do. So here's 120,000 divided by 7,000. And that's going to be $17.14. So that's our fixed cost per unit. We don't know what we're selling, but we know we're selling it for $39.99 in this case. It's some type of floral arrangement. We just don't know which arrangement it is. So the fixed cost per unit is $17.14. The variable cost per unit is $5.25. We want to add those together to get our total. So we have $22.39, and that's our total cost per unit. And the possible net profit is, first, what we need to do is subtract, because remember, we have to do this whole formula here. So we're going to go $39.99 minus what it costs us to have the unit in the building. And then we're going to multiply that by how many we estimate to sell. So in this case, they're estimating the 7,000 if they have it at the price of $39.99. So we're going to multiply by 7,000. So once we get through here, and I can, again, pull up the calculator here so we can kind of see this happening. So we have $39.99 minus $22.39, and that gives us $17.60. That's the actual amount of profit. Even though we're selling it for $39.99, we don't make all of that as profit. It's costing us $22.39 to have that item. And then we're going to multiply by 7,000 because that's how many we are estimating to sell. So we're estimating that this will make us 123,200. So that's our estimate right now. We want to go through and do that for each one. So we're going to divide by 5,000. That'll give us our fixed cost at this price. And then we're going to add these two together to get our total cost, do the same thing. So we're just going to replace this one number, although we are going to replace 7,000 too because it went down to 5,000. Okay, so we're kind of testing. And the question is, which selling price yields the greatest possible profit? So once you fill all three of these in, which one is the best? That's what they're asking you there. So we want to know which one gives us the best profit. And then how many units of the arrangement should be produced to maximize the profits. So with this one, it depends on which one gives us the best. And then we'll look at how many we should make based on that answer. So we're going to choose one of these as the best. And they don't really give you a line to do that. You could either write it up here, that it was the $39.99, the $49.99, or the $44.99 that was the best profit. Or you could even just, point to it and go best profit. There's a couple different ways to do that. As long as you identify which one's the best. And then for part B, again, the estimated unit sales, that tells you how many we should be making to maximize that profit. All right, so let's scooch down here. We're going to do the exact same idea on this one. The only difference with this one is they fill in a little bit less for us here. So Comp Ad manufactures microcircuitry boards. It has a fixed overhead of $240,000. The variable cost to produce each board is 15 cents. The Comp Ad research department believes the company should sell 1 million boards at 55 cents, 1,500,000 boards at 48 cents each, and 2 million boards at 35 cents each. So they give a couple of options. Just like up here, we have 3 different price options and 3 different unit sales options, and we have to decide which one's better. So complete the table below and determine what selling price will maximize Comp Ad's profits. So estimated sales at 55 cents, that was 1 million, right? That's how many they wanted to sell at 55 cents. So we're just filling the table in at this point. We're not really doing any computations, just filling it in. At 48 cents, that was this next one. So that was 1,500,000. And then at 35 cents, that was 2 million boards. So we filled in this first piece here. The fixed costs, well, that doesn't change. The fixed costs are going to be the same for each one. So, 240,000. We're just, again, filling this in, just making sure we're understanding the wording. Fixed cost per unit. So this is where we need to start dividing. So fixed costs per unit. So we're going to do 240,000 divided by 1 million. That'll tell us the fixed cost for this first one. Fixed cost per unit for this next one is 240,000 divided by 15 million, but 1,500,000. And then for the third one, it's 240,000 divided by 2 million. So just make sure you're paying attention, go the correct direction there. Don't do 2 million divided by 240,000. You'll get the wrong answer. You want $240,000, so fixed cost, divided by the number of units you plan to sell. And that'll tell you your fixed cost per unit. So it says it in that order on purpose. Fixed cost first, per means divide, unit is second. That means it's on the bottom of the fraction. All right, so you need to fill in these 3 pieces. I didn't fill those in for you. Variable cost per unit. So they already told us that. Variable cost per unit was 15 cents. That's not going to change. It's just going to be 15 cents for all of them. So the total cost per unit will change because that depends on what you get here in this column. So you're going to add that to the 15 cents, and that'll tell you your total cost per unit. And once you've gotten to this point, your possible net profit, we just have to go through and apply our pieces. So remember, we have to subtract the total cost per unit from how much we plan to sell it for, so we know what is our profit. And then we're going to multiply by how many we plan to sell. So in this first one, we're going to multiply by a million after we do our subtraction. In the second one, we're going to multiply by 1,500,000 after we do our subtraction. And then the third one, we're going to multiply by 2 million, again, after we do our subtraction. And that'll tell us our possible profits for these 3 boxes. Once you have these filled in, you're just deciding which one is the best. Which one should we choose to do? So which one gives us the best possible net profit? And that's the one you're going to choose to write about right up here. Okay. All right, let's go ahead and look at this algebra piece here. Outdoor patio would like a net profit of $1,027,890 on a line of patio furniture. The fixed cost for the production of patio chairs is $23,500, and the variable cost per unit is $155. If estimated unit sales are 47,000 units, what selling price per unit should the company try? All right, and I'm gonna get rid of this page number here just so I have more room. A little bit here. All right. So we want to use the equation possible net, and I'm leaving off the word possible here just to save a little time, equals the selling price minus the cost times the units. So we already know that. That's what they have up above there, right? I just kind of simplified the wording a little bit. So our possible net equals what we're selling it for minus our cost times the units that we're selling. So we already have our units, right? 47,000. That was given to us in the problem here. Our net was also given to us. Remember, net. This is what they want to make. So 1,027,890 equals. We don't know what the selling price should be. That's what they're asking us to find. What selling price per unit should the company be? So we don't know, and I'm just going to leave it S for now. And then minus the cost. Well, do we know the cost yet? Kind of. We know part of it. Remember, the cost has to do with fixed and variable. So we know the variable cost. They told us that right out. The variable cost is $155 per unit or per set. But we need to divide that here because we know the fixed cost is $23,500. And since we're planning on having 47,000 units, we just need to do our quick little calculation there for our cost. So 23,500 divided by, so fixed cost per units equals, and if we do this division, so we have 23,500, whoops, one too many zeros. And swipe back on the phone. I don't know if you can do that on the computer. Divided by 47,000. All right, so we get, oh, did I forget the 5? 23 divided by 47. I did. Darn it. I think I'd forgotten to type in the 5 that first time. So we get 0.5. So we have a fixed cost of 50 cents per unit. We have a variable cost of $1.55 per unit. We just need to add those together. So we end up with, there's a 0 on the end, 5, 10, 2, so it's 205 cost. Now I have my cost and I can plug it in here. So now we just have to go through and start solving this. You can distribute the 47,000 because it's outside of the parentheses, or you can divide both sides by 47,000. I think that might be a little bit easier, but it's kind of up to preference on this one. There's 2 options because these will cancel. You'll have a number after you divide these 2, and it'll equal S minus 205, and you just have to add 205 to both sides in that case. If you distribute, which is, again, still an option, you distribute, so you multiply by 47,000 for both. You're going to have to add that number over here and then divide by 47,000. So you end up dividing by 47,000 anyway. Either way you do this. So I definitely got that one set up for you. I know I didn't do a whole lot of the calculations there. I only did a little bit piece of it, but it's definitely set up. So I'm going to let you guys finish that one off. I hope that helped, and I will see you in chapter 17.